Okay, everybody, let's go through this exam one here. So problem one, we have a tire with a 2-foot radius making a rotation of theta equals 300 degrees as it rolls forward on the ground. Find the distance traveled by a point on the treads of the tire as the tire is rolling. So we have a tire sort of rolling on the ground over here, right? And so there's a point on the very treads of the tire, and that point is, of course, moving as we make our 300-degree rotation. Okay, so let's say that's about 300 degrees over there, right? So now it is, let's say over here, okay? And we want to know what is this distance along the boundary that point is traveled as the tire was rotating. But of course, that's just an arc length. So we're going to use our arc length formula. S is equal to R times theta. The problem with this is that theta needs to be in radians. Okay, so we need to convert our theta to radians. So theta is equal to 300 degrees. To convert it to radians, I need to multiply by pi rads and divide by 180 degrees. And doing that will ensure that my degrees will cancel off, right? And then this, we'll just simplify 300 over 180. They're both divisible by 60. So this will be a 5 pi over 3 rads. So that's my theta. So now just plugging in all this into my arc length formula, we get that S is equal to R, which is 2 feet, times theta, which is 5 pi over 3 rads. All right, and now we have to worry about units. We have feet times radians, right? But when radians gets multiplied by a unit of length, the radians disappears. So this just turns into 10 pi over 3 feet. And in case you're confused about why the radians disappear, well, radians is really just sort of a conversion factor between the radius of a circle and the length of an arc. So if we keep that in mind, it kind of makes sense that when we do multiply by the radius of a circle, we do get the length of the arc instead, which should be measured in feet. Okay, so that's my final answer. Full credit. Okay, a 100-foot tall building casts a shadow on the ground. The angle of elevation between a point on the ground and the tip of the shadow and the sun is measured to be theta equals 75 degrees. Then find the length of the shadow on the ground. Let's again draw a picture here. So we have a building, right, on the ground. Okay, great. And so we have a 75-degree angle of elevation. So this is not to scale at all. 75 degrees, let's say, right over here. Okay, that's great. This is, of course, a right angle over here because the building is sitting upright, so it's perpendicular to the ground. All right, and we want to measure the tip, the distance between the tip of the shadow on the ground and the base of the building. So that would be this distance right over here. Right, I'll call that X. Right, so the length of the shadow. Okay, so we know that the building is 100 feet tall, so then this distance right over here is 100 feet. All right, so then we have all the things we need in order to compute X. All right, now I'm going to use tangent because we know the opposite side and we want the adjacent side, and we know the angle. So then tangent of theta here 75 degrees, supposed to be equal to opposite over adjacent, right? We have 100 over x. And now we need to solve this equation. Now, in order to get x out of the denominator, I got to multiply both sides of the equation by x. So let's do that. So I'll do x times tangent of 75 degrees is equal to x times 100 over x, right? And then now my x's will cancel, right? And over here, I just have x times tangent of 75 degrees, right? Which doesn't look fun, but that's okay. Don't worry about it. We just need to isolate x. So we need to divide by tangent of 75 degrees on both sides, right? So divide by tangent of 75 degrees. Make sure my handwriting doesn't get too awful here. And then now let's see what we get, right? So we'll get our calculator out. I'm not using a fancy calculator today. This one will work just fine. So we have 100, right? We're dividing it by tangent of 75 degrees. So let me make sure I'm in degrees here, not gradients, degrees. So 75, and I need to take tangent of that. All right, so 100 divided by tangent of 75 degrees is 26.79. And my instructions to you in class were to round this to the nearest foot. So that would be about 27 feet. Okay. All right. Okay, let's go on to problem 3. So we have this point 4, -2 on the terminal side of an angle theta in standard position. Find the values of the 6 trigonometric functions of the angle theta. All right, so let's go ahead and draw this point in here just for fun. Okay, so 4, -2, let's say it's about right there. This is on the angle theta right over here. Okay, we didn't really need to draw that angle, but whatever. Right, we have our x-coordinate is 4, our y-coordinate is -2, and our r is always the square root of x squared plus y squared. So let's go ahead and plug it in, see what we get. So we get square root of 16 plus 4, square root of 20, which is the same thing as 2 square root of 5. Okay, and if you're curious how I simplified square root of 20, right? Well, square root of 20 is the same thing as the square root of 4 times 5, just kind of pulling out a perfect square, right? And then square roots distribute over multiplication and division, but not addition and subtraction, right? So we're fortunate this is multiplication over here. So we get this is the square root of 4 times the square root of 5. And of course, square root of 4 is 2 times the square root of 5. So there we have it. Okay, so now we have our x and our y and our r. So we're ready to compute sine and cosine and all the other stuff. Sine of theta is equal to y divided by r. So we're going to get 2 square root of 5 over r, which was, oh, sorry, got my things confused there. My y is -2 over 2 square root of 5. My 2's will cancel off, really. So I get this is really -1 divided by the square root of 5, if I pull the negative out. But I need to rationalize the denominator, so I'm going to multiply by square root of 5 over square root of 5. Upstairs, then, I'm going to get 1 times the square root of 5. And downstairs, I'm going to get a square root of 5 times the square root of 5, which is the square root of 5 squared, which is just 5. Okay, now I'll do cosine of theta, just x over r. So that's going to be a 4 over 2 square root of 5. All right, 4 and my 2 will cancel, just be 2. So I get 2 over the square root of 5. Do the same trick here. Multiply by square root of 5 over square root of 5. So I get 2 square root of 5 upstairs. Square root of 5 times square root of 5 is the square root of 5 squared, which is just 5. Tangent of theta is y divided by x. Oh, I forgot to put my formula over here. See if I can kind of squeeze it in. Cosine of theta equals x over r. And I'm only putting it over here because I'm going to be using it in the next 2 problems also. So I might as well put it in at least once over here. There we go. X over r. Okay. Tangent of theta is y divided by x. So that's going to be a -2 over 4, right? Which simplifies very nicely to be -1/2. Right? We'll do cosecant of theta, right? Which is the reciprocal of sine. So it's r divided by y. Right? Now, now I can use the formulas for this and plug in my r and my y and simplify. But I have this nice form already for what sine of theta is equal to. So if I take the reciprocal of that, I'm just going to get negative square root of 5. All right, we don't need to worry about the algebra then. Yeah. Secant of theta is the reciprocal of cosine. So since I have this nice form for cosine already, I'll just take the reciprocal of that, and I'll get, sorry, I'll write out the formula first, r over x. Take the reciprocal of that, and I get square root of 5 over 2. And then cotangent of theta, right, that's x over y. Take the reciprocal of tangent, and I'm going to get -2 over 1, which is just -2. Okay, so there we have it. All right, so then now suppose that theta is an angle in standard position and that cosecant of theta is equal to 5/3 and secant of theta is less than 0. Now we're going to find the values of the 6 trigonometric functions of theta. All right, so there's 2 steps in this. Step 1, which is absolutely necessary and worth 4 points out of 10, is to determine what quadrant we're in. All right, so what quadrant is theta in? And I find that a lot of students are very lazy when they try to answer this problem. And this is not a good thing to be lazy on when it's something that requires you to explain something. You want to make it as clear as you can, right? So since cosecant of theta is equal to 5/3, I'll start off that way. And nobody likes cosecant, so I'll say this means that sine of theta equals 3/5. All right, and we can all agree with that because sine of theta and cosecant of theta are reciprocals of each other. Okay, But now that we know that sine of theta is equal to 3/5, we can say, thus, sine of theta is greater than 0, right? It's a positive number. 3/5 is definitely bigger than 0, right? So theta lies in either, well, we see which quadrant it could possibly be in, right? We have the all students take calculus, right? So everything's positive in quadrant 1, and sine is positive in quadrant 2, and then it can't be positive in quadrant 3 or quadrant 4 because tangent is positive in quadrant 3 and cosine is positive in quadrant 4. So theta lies in either Q1 or Q2. Okay, that's as much information as we can get out of cosecant of theta. Now, since secant of theta is less than 0, it's a negative number, this means that cosine of theta is also less than 0, right? They're reciprocals of each other, so if one of those is positive, the other one has to be positive. If one of those is negative, the other one has to be negative as well, okay? So theta cannot lie in quadrant 1, right? Everything's positive in quadrant 1, but we need for cosine of theta to be negative. So out of the two possible quadrants, quadrant 1 or quadrant 2, right? It can't be quadrant 1, therefore theta lies in quadrant 2. Okay, fair enough. So that's step 1. Now we know theta lies in quadrant 2. Step 2 is to find our x and our y and our r, and we're told that cosecant of theta is equal to 5/3. Okay, but we also know that cosecant of theta is equal to r divided by y. Okay, so using that information, I get that my r is equal to 5, and my y is equal to 3. Okay, so now that I have that, I know my r and my y. I also know that r squared equals x squared plus y squared. So, or r is equal to the square root of x squared plus y squared, same thing, right? I'll plug in my r is 5, so I get 25, right? I don't know what x is yet, so I get x squared plus my y is 3, so I get plus 9. So this means that my x squared would be 25 minus 9, which is 16. So then I get that x is equal to plus or minus 4, right? Two possible solutions, right? Both of which, when I square them, I get positive 16, okay? So out of those two options, let's see which one it is, since theta lies in quadrant 2, right? Remember this point, xy has to lie on the terminal side of theta. So since theta lies in quadrant 2, that means this point xy has to lie in quadrant 2, which means that x has to be negative, right? So this means x is -4, okay? All right, so now I have that. So now I have my x and my y and my r, right? You can call this step 3 if you want to, but I'm just going to write down what sine and cosine and tangent and the rest of them are now, right? Sine of theta, right? I've written down the formulas before, so I'll skip it now. It's y divided by r. And of course, we already computed that anyway. Cosine of theta is x divided by r. Tangent of theta is y divided by x. Okay. Cosecant of theta was given to us, but there's r over y. Secant of theta is just a reciprocal of cosine. It's also r divided by x. You get -5/4. And then cotangent of theta is a reciprocal of tangent. It's also x over y, -4/3. Okay. And there we have it. All right. Now, problem 5 here, find the values of the 6 trigonometric functions of the angle theta equals 1200 degrees. And remember, I had a particular way I wanted you to do this so we could get used to coterminal angles, reference angles, right, and special angles. But let's do that. So theta is equal to 1200 degrees, right? And so that is going to be coterminal with 1200 degrees minus 360 degrees, okay? Now, 1200 degrees minus 360 degrees is equal to 840 degrees. Check that one more time. Yeah, that's right. Okay, good. But now 840 degrees, that's coterminal with 840 degrees minus 360 degrees, right? And 840 minus 360, that's going to be equal to, let's see, 580 degrees, it looks like. Yeah. No, I can't be right. 580, maybe 480, that's right. I don't know why I'm doing this instead of doing it on a calculator anyway. Let's just check my work here. All right, so we got 1200. We took away 360. So do we get 840? We do. Now we took off another 360 and we get 480. Good. Okay. And then now 480 degrees, that's coterminal with 480 degrees minus 360 degrees, which will be 120 degrees. Okay. All right. So now we have found an angle between 0 and 360 degrees that theta is coterminal with, right? So theta is coterminal with 120 degrees, right? And I'll note that this is in quadrant 2, okay? Why do I care that it's in quadrant 2? It's because we're trying to find a reference angle, and the formula for the reference angle will depend on what quadrant we're in. So my theta prime, in this case, my reference angle, right? Since we're in quadrant 2, it'll just be 180 degrees minus theta. Okay, so we have 180 degrees minus, and we're not actually going to use the value of theta. We're going to use the value of theta that is coterminal with, which is 120 degrees here, right? Because these formulas only work for angles between 0 and 360. So then we get that this is 60 degrees. So my reference angle is 60 degrees. All right. So that if I want to know what sine of 1200 degrees is, okay, well, it's equal to either plus or minus, and we don't know which one yet, sine of the reference angle. Okay. Now, remember when I said that theta is in quadrant 2 over here, right? You know, theta is coterminal to 120 degrees, so it has the same terminal side. So if 120 degrees lies in quadrant 2, so does theta, right? So since we're in quadrant 2, we know that sine should be positive. So then sine of 1200 degrees will be positive sine of 60 degrees and not negative, okay? So just to emphasize this, I'm going to put a plus sign over there. You don't have to put the plus sign. I won't take off for it if you don't. Okay, so positive sine of 60 degrees, and sine of 60 degrees is square root of 3 over 2. Okay. Cosine of 1200 degrees. We're in quadrant 2, so it's going to be negative, right? Negative cosine of 60 degrees, which will be negative 1/2. Okay. Tangent of 1200 degrees. Again, it's going to be negative because we're in quadrant 2. So negative tangent of 60 degrees, right? Remember to use your chart on these. So that's going to be a negative square root of 3. Okay. Now cosecant of 1200 degrees, right, will be positive sine, positive cosecant of 60 degrees. Okay, which is just a reciprocal of sine of 60 degrees. So it's going to be 2 over the square root of 3, which we can rationalize by multiplying by square root of 3 on the top and the bottom. 2 square root of 3 over 3. Okay. Secant of 1200 degrees is going to be negative secant of 60 degrees. Right, so it's just going to be a reciprocal of this, which is negative 2. Right, and then cotangent of 1200 degrees. It's going to be the reciprocal of this, right? So, sorry, it'll be a negative cotangent of 60 degrees. Right, and then it's the reciprocal of this, so it's negative 1 over the square root of 3, otherwise known as negative square root of 3 over 3 after rationalizing. Okay. Now the very last problem over here, right? We're given an angle 18 pi over 7, and we want to find the point on the unit circle that also lies on the terminal side of the angle theta. All right. So you can just remember that if we have an angle, and I don't know what quadrant theta equals 18 pi over 7 lies in, it doesn't actually matter, right? So if we have an angle theta, let's say here in quadrant 3, right? Right, and if we want to point on the unit circle that lies on that angle theta, well, then x will just be cosine of theta, and y will just be sine of theta, right? And why is that? Well, it's because cosine of theta is always equal to x divided by r, right? But since we're talking about the unit circle, my radius is 1 everywhere, right? So it's x over 1, which is just x. So your x coordinate is just cosine of theta. Similarly, sine of theta is y over r, but since your r is equal to 1, right, this is just going to be y. So x will be equal to cosine of 18 pi over 7. Y will be equal to sine of 18 pi over 7. And then it just comes down to plugging this into a calculator and rounding it to 3 decimal places correctly. So let's see what we come up with here. 18 times pi divided by 7. And, oh, we're supposed to be in radians. And then now we'll take the cosine of that. we get negative 0.223. Okay, now we'll do sine 18 times pi divided by 7. And now we'll do sine of that, and we get 0.975. And if you left your answer like this, that's perfectly fine. If you wanted to put it as a point, you get negative 0.223, right? And then 0.975. Okay, perfect.